Hey everybody, how are we doing today? This is part 5 of our second quarter review. Again, here we are in 1 week, 7 to 8 questions a day. We covered an entire 9 weeks worth of work, and hopefully you're going along and doing these basic skills. These are like the level 1, level 2 problems of an EOC test that give you that basic knowledge of algebra, and you're like, hey, man, these are easy. If you feel that way, or if this simple refreshing just sparks it back in your brain, you've done something right all year, okay? So we're going to start off with two things. We're dealing with inequalities today, graphing inequalities and solving systems of inequalities. And then we're going to finish it up with some of our tricky combinations of exponent rules. So remember, the first thing we have to look at when we're doing an inequality, a single inequality, is where it's about lines. Is the line going to be dotted or is the line going to be solid? Okay, so anytime you have the less than, like we have here, the less than or the greater than symbol, remember there's no equal sign under it. Because there's no line under it, it's dotted. It means it doesn't include the answers on that particular line. Okay, and then if the problem happens to be less than or equal to, greater than or equal to, well, then it includes the answers on the line. So this excludes. It's like the open dots. It doesn't include the exact number. Everything as close to it as possible, but not the exact number. And then we have the greater than or equal to, like we were graphing them before. It includes the number that you're graphing, or in this case, it includes all the values on the lines. And since now we're on this Cartesian plane, which is, it's like 2-dimension, okay, we also have shading that's going on. It includes or does not include the line, and it either is going to include everything above the line or everything below the line. And the symbols tell us that. The less than or equal to, says it's less than or equal to the line. So you shade below. Greater than or equal to, it's everything above the line, greater than that line. So the symbols kind of give us the hint as to which way we're shading. We just have to be careful when we're doing it. Okay, so let's look at the first one. X equals 5. The line x equals. Again, Mr. Slope does not go away here. And this happens to be a special case. I made his nose really big. Oh, well. So remember, booger out of the nose. X equals. Y is the tongue coming out of the mouth. Y equals. These are special lines. What did they give us? They gave us a special line. Okay, so we know that. It's a vertical line that crosses the x-axis. Where? What number? At 5. So right away we say we know that we're going to have a line that's here. Well, what kind of line is it? Is it a solid or a dotted line? So we look at the symbol. It's a less than symbol. Okay, so less than is the dotted line. So at 5, we have this dotted line at 5. All right, great. Now in Math Excel, it dots the line for you, so you don't have to worry about it. And then there's a little bucket tool. The bucket tool is basically, it's filling in a section, and it's going to fill in. Are you going to shade the area to the left of the line or to the right of the line? I noticed I said before above or below because every other line that we have is generally above or below. But in this case, if you look at the numbers, anything less than goes to the left of the line. Anything greater than goes to the right of that line. So our symbol is a less than symbol. Less than says we shade below the line or less than the line. So this is the area that's all shaded here. So you use the bucket tool and it would highlight all this side of the graph for you. All right. And your solution, you could pick any single point on this side of the line, and it would make that particular equation true. Okay, so take any value you can think of less than but not including 5 isn't make it true. The x coordinate, grab it. 0. Is 0 less than 5? Yes. Is negative 10 less than 5? Yes. Is 4 less than 5? Yes. Is 4.999999999 less than 5? Yes. That's how you do that one. Here we go. Determine whether the ordered pair is a solution to the inequality. Okay. So an ordered pair is an x and a y. And they want to know, is this one of the, would this be on this side of the, in the shaded region? So if it is, it will make the equation true. So all we have to do is use our substitution law. Imagine we've used that substitution rule a whole lot this year. Plug in your x, plug in your y, and see, are we dealing with something that's true? All right, so we take this, we're going to gank out that y here and put in the y they give us, less than or equal to negative 5. Remove the x and plug in a 1. Now we evaluate and simplify because our goal is to get rid of these parentheses. So negative 1 is less than or equal to, we distribute, negative 5. So is negative 1 less than or equal to negative 5? That seems weird. Let's take a look. How would this appear on a number line? So we have 0 is over here, then we have a negative 1, then it's negative 2, 3, 4, and 5. Is negative 1, is this negative 1, is it less than or equal to negative 5? No, that is not true. So because this is not true, the point 1 comma negative 1 is not part of the solution. Next one is graph the system of inequalities. Using the graphing tool on the right to graph the system. Now notice what we did up here with the x equals. Okay, that wasn't a system of inequalities. That was just graphing a single inequality. One line, dotted, or solid. Are you shading above or below? Now we have a system. So we have 2 equations that we have to graph. Okay. Sometimes, look, this first one, y equals mx plus b. Yes, I know that there is a inequality symbol in there, but it doesn't change that slope-intercept form. Okay, that still means that 4 is the slope and negative 3 is your intercept. Okay, so come down here, negative 3, drop your intercept. And then our slope is a positive 4, so that means rise over 1, 4 over 1. We go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Great. And Math Excel, of course, is going to draw that line for you. Is this solid or dotted? This is a dotted line. 1, 2, 3, 4 over 1. I'll just expand the dots. So here's our dotted line. Okay, it goes off the grid here, but it keeps on going forever. Now, are we going to shade above or below this particular line? So we're going to shade above. So everything on this side of this line is shaded. Okay. Now we need to do the next line. Oh boy, that line is in standard form. That is not what we like to deal with when we have to graph something. So you have 2 options. You can either find your y-intercepts, what's your y-intercept, what's your x-intercept, plot it on Math Excel, super easy. Or you could solve that equation for y and turn it into slope-intercept form. I'm going to do that just so we're on the same page as graphing. I find it easier to graph as in slope-intercept form, and it builds your skills on solving. So we're going to solve this. I need to move the x over, so I have to add x to both sides. 3y is less than or equal to x plus 12. Now I have to divide by 3. Divide by 3. Divide by 3. Notice we divided by a positive number, so that inequality sign stays the same. So y is less than or equal to 1/3 x plus 4. So this was not bad. I'm going to try to change colors again. Every time I change colors, it wants to do something funny. Perfect. Okay, now I'm good. So I'm going to do the second line in blue. So our intercept is 4, so I have a dot here at 4. And our slope was 1/3, so that means it's going up 1, and to the right, 1, 2, 3. And I'm just applying slope both ways since I don't have the fancy graphing tool. Here's the line. So, oops, that point's in the wrong spot. Gotta love technology. Up 1. Up 1. Down 1 over 3. This gives us enough of an idea of what we're dealing with. Now, is this going to be a solid or dotted line? Look, it's the equal to. So the equal to says yes. So we're dealing with, from here, it is this, and apologies for this line, it's not perfectly straight, solid line. So we have one line here. The dots make up our dotted line. We have the other line here. We've shaded everything above on one. This symbol says less than. So we need to shade below the solid line because the less than symbol says below the dotted line. So if we're going to go below this, I'm sorry, the solid line, we just go below it. Everything below it gets shaded. So now here was our first dotted line. Okay, here's our solid line. Notice up here, it's only shaded by 1. Up here, there's no shading. Down here, only shaded by 1. But in this particular section, so it's very, this section through here, but not including this line, including this one, not, this is where our double shaded region is. That's the quarter of where these two lines, because these two lines meet and give you 4 weird shaped quadrants. Okay, that's the quadrant that would have all of your particular answers in it. So here's a way to test this point right here. You can test this. This is the point 0, 0. It's the origin. If you were to plug a 0, 0 into this, okay, 0, this 0 here cancels out this, so this would be gone. And so we have 0 is greater than -3. Is that true? Yes. And if you plug a 0 in here, this turns to 0. You plug a 0 in here, this turns to 0. 0 minus 0 is 0. Is 0 less than or equal to 12? Yes, it's true. And that would happen to any one of these points that you pick from the shaded region. It's true for both equations. I always, if the point 0, 0 falls inside of the double shaded region, choose that as the point. It's the easiest one to work, guys. Moving on. All right, for this particular one, from here on out, what are we doing? We're just doing our rules, our power rules. So remember, in order to first off do anything, we don't magically combine bases that are different. We can only deal with bases that are the same. Anything to the 0 power equals 1. Anything to a negative power, well, that power has to go downstairs in order to become positive. So it becomes 1 over x. Okay, to the positive 1. It's like an invisible 1, positive 1 power. Then we had multiplying two bases. if the bases are the same. So if you have x squared times x to the third power, our rule was the base stays the same and you add the exponents. All right. The next one that we had was, what was it? Division. If we divide 2, okay, the bigger power sits down below. So as it sits down below here, what do we need to do? We have to subtract. Base stays the same. You subtract the exponents wherever the larger of the two exponents lives. So in this case, the bigger exponent lives in the denominator. So that's what you do. That x squared is going to come downstairs. And then you'll have a 3 minus 2. And you simplify to 1 over x. And the last rule that we had was a power to power rule. So if you have x squared and it is being raised to the power of 3, base stays the same. You multiply the two exponents. So you would have x to the 15th power. The 0 power rule, negative power rule, multiplication of powers, division of powers, and power to power rule. Okay, let's look at these problems they're asking us. Here we go. The first one, it's what it's having us multiply. So you might say, hey, I got to multiply those two together means I add the exponents. No, your bases are different. Notice what happened. One exponent is not the same from the other. And so this one, what's the key? It has a negative exponent. Only thing we have to do is say we don't want to have a negative exponent. So we have to bring it downstairs into the denominator. So x to the 5th. We bring that y to the negative second power downstairs, and then it becomes positive. Is that one of our answer choices? Yes, it is. Notice, what did they have? X, Y, where they're sitting here trying to like create different rules for this, but it kind of gives you the thing, like if you want to say, hey, I want to take 5 minus 2, you should get a power of 3. Notice they gave you 2 distractors in here. Don't be confused by it. Know your rules, okay? Here we go. We have, look, this time the base is 7. Great. We can definitely do that. So they want you to type your answer using positive exponents. Simplify your answer. So here we go. We're going to have what? 7 to the 9th power, 7 to the 8th power. So it's 7 to the 9 plus 8 power. And 9 plus 8 is what? I hope you know it. We use these calculators and then we forget all of our math skills. 17. 7 to the 17th power. I don't believe they're having you actually calculate that. They just want you to represent your answer like this so you know what your rule was, okay? Here's the power to power rule. So that's c raised to the c to the 4th power, and then that raised. Power to power is multiplication. 4 times 7. You fill it in. I know you can do 4 times 7. Here we go, 41. 41 is our division rule. So the larger exponent lives in the numerator. So that means we need to bring this up to the numerator as well. And you subtract the 2. I know that you can finish this off. All right, so you have to know, well, what power is it being raised to? And here's the one that's more confusing. It's all of it together, all of it mixed up with coefficients. So yes, is there coefficients there? Absolutely. we have to deal with this there's a coefficient, we have x variables, and we have y variables. So you'd want to deal with each part individually. We may have a fraction in the end, we may not. We just have to deal with it individually, and then we'll deal with it first. So let's take on the whole numbers first. That would be 48 divided by 6. So if you do 48 divided by 6, you should get 8. So we know 8 is going to be part of our answer. Great, we've dealt with these. These are done. Now let's deal with our x's. What's the division rule? So where does the larger exponent live? The larger exponent lives upstairs. So we got to bring that little x upstairs. So x to the 2 minus 1 power. Great. Now we have to deal with the y's. These x's have been taken care of. We have 7, or y to the 7th power divided by y. Well, the larger exponent is upstairs. So we need to bring the little y up as well. Y to the 7 minus 1 power. Now we simplify. 8 x to the, well, 2 minus 1 is 1. Do we write the 1? No, we don't put the invisible math in. And then 7 minus 1 is 6. So y to the 6th power. And you would be done. You have just simplified this radical expression here. Okay? We have to be very careful. Just be careful. As I talked about and gave you examples of all the different rules that we use all your rules in each of these. Be careful. They gave you an individual one each, and then they're going to give you a chunked problem where all the little chunks have been stuck together. Tackle it one step at a time. Everything I've done in algebra all year long has been taking complicated things and basically breaking them down into steps of addition, subtraction, or multiplication, or division. Okay, first step here, divide. Second step, well, you use your rule, and then what is the actual math you're doing? Follow the directions. It's why I've been so strong about following directions all year, guys. That's all algebra is. The rule gives you a set of directions, follow it, and then what's the actual math we're doing? 2 minus 1. The next one, the y's. Follow the rule. What's the actual math? 7 minus 1. We all have the ability to do 7 minus 1, 2 minus 1, and 48 divided by 6. Do we have the ability to learn rules and follow directions? That's what was really taught to you this year. All right, quarter 2 is done. Get busy, finish it up. Guys, it's so important. I'm just so happy that we've been able to get this. I'm not happy I don't get to see you in class, but guys, I'm proud of you. I know you've done a lot of hard work this year. Put it to the good use. All right, have fun. Enjoy your weekend.